Okay, so this video is about finding the number of solutions to a system. And to do that, we're going to start by looking at some graphs. Although technically, really the next video is solving by graphing, but we need to kind of look at the graphs to understand what's happening here. And really what we're going to do though is more so look at the equations and decide from the equations themselves what's going to happen with these. Okay, but we're going to look at the graphs first to help us with that. Okay, so the last video was about checking a solution to a system. And we said it has to be an ordered pair that works in both of our equations, meaning when we plug in that x and y coordinate into both of them, it produces a true statement. Now, most of the time, okay, the way that we're going to get that ordered pair is just the fact that our two lines intersect somewhere. And when our two lines intersect, okay, that ordered pair is going to be the solution of a system. Okay. So before we look at those equations, let's look at our other graphs to see what our special cases are, because we do have these cases sometimes. In our middle graph, we have two parallel lines. Now, hopefully you've heard of parallel before. Parallel means they're in a way where they are never going to touch. Okay. And if we look at the equations of those lines, okay, we have y equals x plus 3 and y equals x plus 1. I believe that's a plus. Okay. What's happening here is they both have a slope of 1. There's that invisible 1 in front of the x in both of the equations. And that is why these are, I mean, it makes sense. They're rising and running at the same rate, which is why they're never going to kind of collide into each other. What's also important, though, is that not only do they have the same slope, but they also have different y-intercepts. Okay. And when we have that type of system where we have two equations, okay, that have the same slope and the same but different y-intercepts, that means there's going to be no solution. Because if it's supposed to be where they intersect and they're not intersecting, that means nothing is going to work. Okay. And I do want to note that before you decide if things are parallel because they have the same slope and different y-intercepts, you should make sure that they're both in slope-intercept form first, which is why we did that first video of this topic. Okay, but both of these are in y equals mx plus b form, and you can tell, hey, the slope is 1, different y-intercepts. These are going to have no solution because if we graph them, they would never crisscross. Okay, now the reason the whole different y-intercepts is important is because of our other scenario on the right-hand side here, where we have two equations. Okay, we have x plus y equals -2 and 3x plus 3y equals -6. But the problem is those are not in slope-intercept form. So let's take a second real quick, and I know we don't have tons of room. If you need to do it on the side of your paper, that's fine, but I'm going to try and squish it in. Let's put these into slope-intercept form. Okay. So normally I show my steps, but due to lack of space, for the top one, if we want y by itself, we would just have to subtract x. So that one becomes y equals -x minus 2, because we do x's first. For the bottom one, we would subtract the 3x first to get rid of the 3x from the left side. So it would become 3y equals -3x minus 6. But then we'd have to divide by the 3 into everything. So that's going to become y equals -x, and -6 divided by 3 would be -2. And what actually happened is, even though it looked like we had two different equations, in the end, we actually ended up with the same exact equation. So if you went to graph it, it'd almost be a little bit silly because it's like, well, it's the same line. Why do I have to graph it twice? So if you were to graph it, you would really only see the one equation, sorry, the one line on there, because it'd be the same thing both times. Okay. But most of the time at this point, you'd be like, oh, I have the exact same equation. In this case, if we're talking about where our lines intersect, well, guess what? Everything intersects. So this is our special case where we have infinitely many solutions. So if we get two equations, when you put them in slope-intercept form, that are exactly the same, and put that in there, exactly the same. So same slope and same y-intercept, That's how you know it's going to be infinite solutions. Okay, so just to recap so far, our middle graph, we talked about our parallel lines, same slope, different y-intercepts. Okay, for our infinite many solutions, they were exactly the same slope and same y-intercepts. Any other time, if the slopes are different, there's only going to be one answer. Okay, because they're not going to be parallel if they have different slopes, and they are not going to be the same line if they have different slopes. So if you have a system of equations, and once again, they should be in slope-intercept form before you decide this, if they have different slopes, okay, no matter what their intercepts are, okay, they will only have one solution. And that's all we're caring about right now. We're not actually talking about what that solution is. Okay. So once again, just recapping, different slopes, one solution. Same slope, different y-intercepts, no solution. Exactly the same, infinite solutions. Okay. So let's just do a couple quick examples at the bottom here that don't have graphs. So we're literally just looking at their equations. So this one here, we're looking at this y equals x plus 1 and y equals 2x plus 2. How many solutions does it have? Well, kind of what's determining things is, do they have same slope or different slope? Because same slope is those weird cases, different slope is just 1. So here, this one has a slope of 1, because there's that invisible 1 there. So that has a slope of 1. That one has a slope of 2. Okay, they have different slopes. So that was our first column above. Okay, so this is only going to have one solution. The equations have different slopes. So their lines are going to intersect at one point. That's it. Not talking about what it is right now. That'll be the next lesson. Okay, just different slopes. It's got to have one solution. Okay, and then at the bottom, letter A, they are in slope-intercept form for us again. That is nice. I'm looking at the slopes. I happen to see that they both have a slope of -3. So this is one of our weird cases. So they have a slope of -3, but different y-intercepts. Okay. They're both 5, but one's positive and one's negative. So in this case, same slope, different y-intercepts. That means our lines would be parallel. Okay, but our actual answer to the system, we would say no solution. They would never intersect. Okay, and letter B, the top one's in slope-intercept form. That is nice, but our bottom one is not. And it's actually kind of just in a weird form right now. We have x's and y's and numbers all on the left side. So even though this isn't quite like the ones we did before, okay, we're still going to make sure in the end it looks like y equals mx plus b. So let's get, I don't know, it doesn't matter what we do first. We can do the x's first, the constant first, doesn't matter. Let's start with the constant. So I'll say let's get rid of that -20 by adding 20. So it becomes 5y minus 15x equals 20. So constant to the right. We also need our x's to the other side. So if it's minus 15x, we're going to add 15x. Remember, they are not like terms, so we are not combining those together. We are going to list our x's first so that it is 15x and a positive 20. And then lastly, we must divide everything by 5, and we get y equals 3x plus 4. So remember, this was our first equation we were looking at right here. This is now our second equation we were looking at because we turned it into slope-intercept form. We see they are exactly the same. Same slope, same y-intercept. They are exactly the same. So our answer to this one be infinitely many solutions. Okay. So the key to this, make sure they're in slope-intercept form. Check the slopes. If they're different slopes, one solution. If they're the same, that's when you look at the y-intercept to say, are they parallel, so no solution? Or are they the same equation so that you have your infinitely many solutions?